Good evening, everyone. Is my slide visible and voice clear? Please let me know. Hello. Good evening, everyone. My name is Ram Kumar Deshmukh, and I am the TA for this subject of course Novel Technologies for Food Processing and Shelf-Life Extension, where we discuss some of the previous year assignment, so you can solve current session assignment with the help of what is a method or what tricks and how can you solve this session techniques questions. So here we will discuss some of the question like 10 to 15 or whatever will happen in the 1 hour. So before going to the question, I will tell you a little bit about me. My name is Ram Kumar Deshmukh and I am doing PhD at IIT Roorkee, and this is my mail ID. If you have some questions or if you have some doubts, you can write me to this mail ID. So whenever I will get it, I will reply accordingly. Uh, for my previous education, I have done my bachelor's in technology in dairy technology in College of Dairy Science and Food Technology, Raipur, Durg, Chhattisgarh. Then after BTech, I joined as an MTech in Food Science Technology from Sambalpur University during 2016 to 18. After that, I joined as a junior research fellow at Nittam Tanjavur for 15 months. Then COVID hit, and that time I couldn't get anywhere. Then August 2021, I joined as a project assistant at my present institute, Indian IIT Roorkee, at Department of Paper Technology under the guidance of Professor Kirtidas Gaikwad. After the completion of my project, I joined here as a PhD. And the May cycle, it's a ninth cycle. I got selected for PMRF, that is Prime Minister Research Fellowship, and in that fellowship, we have a duty to teach at least one class per week. For the requirement is there. So this is my course. This is where I explain you some of the questions, and if you have any doubt, you can tell me there, and we will solve it together. And I have also done some industrial internship during my BTech, which was in the dairy plant. And this is my Google Research Scholar profile. So, if you're planning to be a research scholar or you want to go for academia, you might want to create this kind of profile. So, whatever research you are doing, so when you get any publication, your publication will reflect on this profile and their index, how many times it was cited, H index and IH index. So you will get like this profile. So I was able to publish some of the publication, and you can see this profile. So according, if you have a doubt how to create this profile or how you can go publish, so you can write me to the mail ID also. If I can guide you, I would be happy. Okay, so first question is what is the respiration quotient? for the following reaction. So this is this we have a following reaction is there. So we want to find what is the respiration quotient. So what you need to do, you just need to put one formula and you will get your answer. So if you know, please let me know in the comment box. Then I will tell you what is the answer. Respiration, like how much O2 we take and how much CO2 we uh, like uh, like uh, when we take breath in, breath out. So when we breathe in oxygen and breathe out the CO2, so it is called respiration quotient. So you need to find out what is the respiration quotient for the following reaction. So every reaction has their O2 and CO2 intake or outlet. So you need to find out what will be the respiration quotient for this reaction. So for this detailed answer is there. So we know that respiration quotient is a respiration unit of what unit of CO2 has been okay breathe out and what unit of O2 has been taken. So respiration quotient has rCO2 and RO2. So we have CO2 quantity or the molecules 102, okay, and 145 is the O2. So just you need to put this formula and you will get, so 1102 by 145, that is zero point 0.7. So what will be the answer? The answer is C, zero point 0.7. So that will be the respiration quotient for this question. Which of the following gas packaging system is suitable for the both retail and catering packaging of meat, fish, and prepared meal? So option A is a Gamma packaging system, deep draw machine system, flow pack machine system, and vacuum chamber machine system. So if you know, please write answer in the comment box. Okay, here you have to answer which kind of packaging system is suitable. So we can pack the retail or catering packaging. Okay, for meat and fish kind of and prepared meal. So what meat है आपका meat है fish है and the prepared meal. So which kind of packaging system, gas packaging system is suitable? So if you know, please write answer in the comment box and I'll let you know what will the correct answer for this question. Okay, today what happened? Today in our institutes, internet breakdown has been going on. So there is no Wi-Fi. I have connected to the my mobile phone. So if any trouble you face with the screen or my voice, please let me know. Then I will again fix it or again reconnect it, so we can have no problem. Okay, please answer the question. And this videos will be also available online on a YouTube. Okay, if you want to watch it later, you can watch uh, that. And we will also provide maybe that NPTEL team provide you the backup video and PPT for this, so you will get all the information. The PPT also you can get from the link, so you have no worry. You have to no worry about the material or whatever video we are going to. But in the online interaction or live videos, live classes, what you can do, you can ask your doubts here. So I can tell you directly, uh, that is not possible for the recorded video. I think you understand this. So if you have any problem, you can directly ask me. So for this question, we will go. So for this vacuum chamber machine system, mainly meat fish kind of product is uh, packed with a vacuum chamber. Okay, so we removed all the O2 or oxygen present in the packaging material. So there should not be any availability of oxygen. So it will not grow any bacteria or any kind of contamination should not be there, or even after the packaging should not any presence of any um, oxygen. So it will not grow any kind of bacteria or spoiling microorganisms inside the meat or fish. So that is mostly preferred for the packaging of meat, fish, and prepared meal. So deep in detailed solution, we have given deep draw machines are generally used for the rigid and semi-rigid packages, and flow pack machine, horizontal and vertical machines. Then that you use for the flexible pillow pack pouches. If you have seen that pillow, some like you have seen uh, your chips, that is kind of pillow pack. Okay, it has a pillow like structure. So that flow pack machine is used for that kind of packaging. The gamela packaging are used only for retail packaging, and the vacuum chamber machine system is suitable for the both retail and catering packaging of meat, fish, and nuts and prepared meal. So option D is the right answer for our question. So vacuum chamber machine system is suitable for the both retail and catering packaging of meat, fish, and prepared meal. So we have a third question is a numerical question. Kiwi fruits stored in a controlled atmospheric storage unit produce ethylene at the rate of zero point 0.1 microliter kg uh, per kg per hour. If the required ethylene concentration inside the storage unit is 40 ppb or parts per billion, then what will be the output capacity of ethylene decomposer in meter cube per hour for 2 tons of kiwi fruits with the efficiency ratio of 0.95. So you have option A, B, C, D. If your answer lies between these, so that will be your answer. So I will give you 2 to 3 minutes. If you can solve it, okay, please try to solve and let me know if you can solve. Then we will solve it together. This kind of questions emerges when you are doing the storage application for your fruits and vegetables. When we collect a fruit and vegetable from the producer, and we have stored it, and we are ready to retail, we are ready to sell them in retail. Okay, so we need to store, or during the transportation, or during ripening we need to store those fruits and vegetables. So this is the question related to that in that moment. Okay, so you need to find out the required ethylene concentration. So what amount of ethylene do we need, and that has been given that 40 parts per billion ppb, and then what will be the output capacity of ethylene. So ethylene decomposers capacity we need to find out for 2 tons of kiwi fruits. Okay, 2 tons of kiwi fruits we have. So what capacity ethylene decomposer do we need? Okay, so detailed solution we have given. Total quantity of kiwi fruits we have 2 tons equal to 2000 kg. Ethylene production unit by fruits is a point 0.1 microliter per kg per hour. So required ethylene concentration is given 40 40 ppb. So we will convert into that 40 per parts per billion. Okay, so 40 into 10 raised to power 3. The efficiency ratio has been given 0.95. So capacity of the ethylene decomposer we can find out by the equation of the ethylene production unit into the total quantity of kiwi fruit upon the required ethylene concentration and the efficiency ratio. So we have a R, that is a zero point 0.1. Okay, then M, that is total quantity of kiwi fruit, that is 2000 kg upon that your concentration has given required ethylene concentration given is 40 uh, ppb. Okay, so that we have converted into ppm, that is 40 into 10 is power 3 ppm. Then we have efficiency ratio, that is 0.95. So if you will solve uh, this equation or this formula, so you will get 5263.15 liter per hour. So if you will convert into meter cube per hour, so that will be what will be the our answer, 5.26. So that 5.26 comes under the 5.23, 5.22, 5.3. So what will be the answer? The option A is a right option for this question. Okay, you're getting this? Hello, Mayuri, are you getting this? You just need one formula, and you have given everything here. So you just need to remember this formula, then you can solve it. Okay, so next question is question number 4. That is, when there is no increase in the respiration rate of food material with changing the temperature, the value of Q10 is. Okay, so you need to tell what will be the value of Q10 is. Option A is 10, B is 1, C is 0, sorry, and D is infinity. So please answer in the comment box, then I will I will tell you what will be the correct answer. So when there is no increase in the respiration rate of food material with changing the temperature, the Q10 value will be 1. The temperature coefficient over 100 degrees centigrade intervals describes how the respiration of the commodity changes as the temperature is raised or lowered. The Q10 value are usually higher between 0 degree centigrade and 100 degree centigrade. That is Q10 is equal to 2. Q10 lies between 2.4 to 2.5 to 4 and decreases up to 1. So no increase as the temperature near the tissue thermal death limit. So there is the Q10 value will be 1 if there will be no increase in the respiration rate of food material with change in the temperature. Okay, so that is your answer 1. Question 5. In spray coating method, the spraying method deteriorated with the increase the fluid viscosity, increase in operating pressure, increase in fluid temperature, and D all of the above. You need to tell in the spray coating method. Okay, coating is a method when we want to coating is just like putting another layer on some substrate. Okay, so you have seen your apples. you have seen your fruits that is very costly fruits. If you have I don't know you if you have noticed or not noticed, okay, that when you get your apple, okay, so you will find like it is a it is very uh, glowing, okay. So that glow is due to that coating. Some kind of coating is applied to prevent it from the external factor like moisture. Okay, so moisture cannot be loose through that coating, and some microorganisms also we can protect. So it is kind of protection layer, and also it enhances the appearance of your fruit. So this kind of coating usually done, and in the packaging industry for fruits and vegetable, the coating application is has been increased tremendously. So in that application, the spray coating method is a technique, okay, where we spray coating materials on the fruit. Spray like that is sprinkle machine. If you have gone to any place, okay, like लाइक फुस-फुस वाला जो होता है जहाँ से हम पानी-वानी भी वो करते हैं, तो दैट दैट वर्क्स ऑन द दिस काइंड ऑफ principle, okay. So we spray the coating material on the fruit substrate, and it will deposit on the layer, on the outer layer of the fruit, and it will protect for some time when we transport or when we buy or the retailing for limited time, okay. So the spraying pattern deteriorate. So what is the pattern? So if the deteriorating, if the spraying pattern is deteriorate, so what is the factor that is related with the spraying pattern deterioration? So increase of the fluid viscosity, increase in the opening pressure, increase in the fluid temperature, or all of the above. So you need to tell answer. Uh, Please answer, because if it doesn't matter you're giving right or wrong answer. If you think if you think like, okay, on given four options, if you can answer like A or B or C or D, whatever you think, you can try at least once. So at least your mind will work, so if you are going to the right direction or not, how you can think during the exam, uh, and you can get numbers. So I believe you have registered for the upcoming exams. I think dates is over, okay. Dates is over for the registration. uh, I have I don't know exactly, but I also received the registration date expiry, okay. So they were asking register as soon as possible for the exam. So if you have registered, you will get chance, or you will have to you will get chance to attend the examination, and after the uh, qualifying numbers, they will give you the certificates. If you are attending the class, I assume that you have registered, that's why you are attending the classes, okay. So please answer the question if you know, then I will let you know what will be the answer for this question. So in spraying coating method, spray coating method, increase of the fluid viscosity, okay, so that will deteriorate. So viscosity is, what is viscosity? Viscosity is, it is resistant to flow, okay. So if your coating material is very viscous, so it will not come out from the your sprayer, okay. What will be the sprayer will be there, so it will delay, or it will cause, it will there will be no continuous spraying on the food material. So it will definitely deteriorate the spraying pattern of your fruit or vegetable. So in spray coating method, spraying pattern deteriorates with the increase of fluid viscosity, whereas it improves with increase in the operating pressure and uh, fluid temperature. Okay, so one thing you need to know that if there is increase in viscosity, you can increase operating pressure also. You can increase the operating pressure, but ultimately what will happen if your fluid has a highly viscous, so it is very difficult, it is very difficult for the your sprayer or what kind of spray you are using, that machinery. Okay, so basically what this question is depicting that your fluid should have a optimum viscosity, so it should not be very low or it should not be very high, otherwise your coating will be not fine, so that will deteriorate, or that will not have a good pattern, or that will be not uniform pattern of coating on your whatever substrate you are coating. So increase in the fluid viscosity that deteriorate, or that they diminish the quality of spraying pattern. So that is the answer. And the question 6 is, in edible coating technology, which among the following option shows the correct relationship between the equilibrium coefficient and adhesive force and cohesive force? So you have options A, B, C, D. So you know, if you know, please write answer on the comment box. Please write whether you know or don't know. Okay, if you are wrong also, it doesn't have any impact now. So you can answer at least. Okay, Mayuri, please ask if you want. Do you have any question? You can unmute yourself and ask me whatever question you have, or you can at least guess. Okay, जैसे उसमें होता है केबीसी में जैसे होता है, or whatever question, whatever the multiple option you have questions. Okay, so you need to select one option. So like that you can select, or if you know that is more than good, so you can answer one of the, you can select one of the options. Whether you're right or wrong, I will tell you later. So please answer on the comment box. And if you have raised your hand, okay, I might like you have some questions, so you have raised. Otherwise, you don't need to raise your hand. You can answer in the comment box. Okay, so the time is over now. So the correct relationship between the equilibrium is spreading coefficient, that is spreading coefficient equal to adhesive force minus cohesive force. It can only be negative or zero. So that your spreading coefficient means how much your product, how much your coating material. Okay, in edible coating means the coating material is edible, you can eat it after coating. Like we assume that in the coating of fruits and vegetables, that should be edible. Okay, whether after purchasing you are washing or not, but it is recommended to wash it, because it is the fruits and vegetable market. Okay, you are going to fruits and vegetable market, so your fruit surface is not that much sterile. Okay, so that will be uh, different dust particles always will be there. Some insects can be there, small insects you sometimes we cannot see. So it is advisable, but if even if you forget to wash that, you can eat it. Okay, you don't need to you will not hamper any you will not face any health problem. So that is the spreading coefficient. So how much your that coating material will be spread, so you, there is adhesive force means the how much your coating will stick to your surface, and cohesive force means that how much your material, that component has the stickiness or that cohesive force which will impact the spreading coefficient, so that you have two factors, adhesive and cohesive. So you need to find you need to answer in this question. So what is the correct answer? That is a C. That is a equilibrium spreading coefficient equal to uh, adhesive force minus cohesive force. So that is a correct answer. Okay, so question 7. Which among the following material characteristic is not true for chitosan? So chitosan is a biopolymer. So you need to answer which of the material characteristics we have given four options: high water permeability, high water resistant, poor mechanical property, and high glass barrier. So if you know, you can answer whether it is A, B, or C, D in the comment box. I'll give you 2 to 3 minutes. Then I will tell you what is the correct answer for this. Uh, Nancy, Mayuri, Varuni, you can answer if you know whether it is right or wrong. It doesn't matter. And these classes will also be available on online YouTube. You can watch it if you cannot continue the class, or if you have forget to attend the classes in any classes like previous week, in last week, or any week. Okay, from first week we are going to attend. This is our seventh week class. Okay, so if you have missed any classes, so you can watch from the YouTube channel also. There we have all the uh, videos available on that channel, so you can watch anytime you want. And if you have any question, you can write me to the mail address. I will be happy to answer you in any kind of your doubts. So please answer which of the following material is not true for the chitosan. Okay, so Mayuri Kadam has given high water permeability. Okay, anyone else? Please write whatever you feel. It is not like that. If you will give a wrong answer, I will you will get lower mark or anything. Nobody knows here anyone. Okay, so you can tell freely. Uh, that is a that is a online classes. Now, if you are telling the right wrong answer, also I cannot do anything. I can tell you the right answer only. Okay, so it is not like offline classes. If you have given wrong answer and teacher will beat you, it is not like that, na. And beating is also out of the table. Okay, Nancy Kumari is saying high gas barrier. Okay, Varuni, if you want to add, okay, if you have any option, you can also give. So that the B will be the right option, the high water resistant. Okay, high water permeability, high water resistant, and poor mechanical properties, high gases barrier. Barrier means that will resist to go inside. Okay, suppose I have this paper, I have this tissue paper. Okay, tissue paper I have. Okay, if I put some water, okay, and if it register, okay, if I have put some water here and it is not going or it is not waiting, okay, so it will tell it has a high water resistant or water barrier property. If I am putting some gas, okay, if it is my packaging material, okay, and outer, if inside O2 is lower and outside is 21%, okay, we know. So after some time, if the concentration is not changing, so it has high gas barrier also, whether from the inside or outside, it is not going inside, and the gases inside is also not changing. Okay, sometimes if your product had some nitrogen or carbon dioxide gas, okay, So it should not go outside also, otherwise your composition will be altered. That is not good for your product. And high water permeability is, that is water is permeating. If I'm putting some water here and that is going down, it is going one side from other side, so that is a high water permeability. And uh, mechanical properties, like mechanical, if I if I will pull like this, okay, from both side, it will break easily because it is a paper, it is just a tissue paper, so it has a very poor mechanical property. So this kind of, every material has different characteristics. So for this chitosan, this is a high water resistant. Chitosan exhibits a property like high water permeability, lack of water resistant, poor mechanical, and high gas barrier. But that high water resistance is the best answer for this. Yes. Orange juice is aseptically packed in the laminated pouches and held at 25 degrees centigrade. The degree of the degree of browning as optical density at 420 nanometer measured on the first day is zero point 0.1 in the juice. Browning reaction follows a zero order reaction. The rate constant for juice is 2.375 into 10 raised to power 3 minus 3 OD per day. Calculate the shelf life of juice in days. In the juice becomes unacceptable when degree of browning exceeds 0.30 OD optical density. Okay, so here you need to find out what will be the shelf life. So now you see, okay, uh, you can find out the shelf life also with some some data will be given you, and you can find out what will be the shelf life. Suppose you are buying some packaged material or some juices, okay, and we are giving you some data for that particular product, so you can calculate how many days your product can be safer for the human consumption. So if you know, you please let me know the answer in the comment box, then we will solve it together. Okay, like I told you, if you're attending the classes, I believe you have registered for the exams. So prepare well for exam, because I think it is in the month of uh, month of April, I think. I believe so. So prepare well if you want to get the certificate, because if you are attending the class, you might to related to the food technology or food sciences background. So you might want to appear for the NET or GATE exams. Okay, and you want to go further, like if you are into BTech, you want to go for MTech, or if you are in a MTech, so you might want to go for PhD. So that is depending upon your interest, or that is not necessary. If you want to go to for job also, that you should know the basics of this kind of food preservation and calculation. We are here, if you are reading, if you are attending the classes, main classes, okay, that is taught by the Professor H. N. Mishra from the IIT Kharagpur. So he has taught it very well, and explained it very nicely, everything, and in detail. I know that questions will not be that kind of question, but he has there in the course curricular. There are some formula you have seen in the videos also, so you can uh, get some idea how you can solve the questions from that also. So if you will attend those classes, then only you can understand these lectures or these doubt session classes. Okay, so let me brief you. So we have given the initial value of browning, that is zero point 0 optical density, and final value at point 0, point 30, and point 10. First is initial and second is a final. The rate constant is a 2.375 into 10 raised to power 3 shelf life. So what is a shelf life shelf life equation? That is a final value of Browning degree, okay, that is Be minus initial value of Browning degree, that is 0.10 upon the rate constant. So you have 0.30 minus 0.10 upon 2.375 into 10 raised to power 3. If you will solve this equation, you will get 84.2 days. So we have option 84.2, that lies between 84 to 85 days. So what is the correct answer? The D option is the correct answer. So your juice is your juice has a 84 days shelf life. So you can consume it safely for 84 days. Okay, so that you take this is looking very dangerous. Okay, it has a like 5 lines question, but if you know the correct formula, you can solve it within minute. So this is the formula based questions. If you remember the formula, you can solve it very quickly within 1 minute. Like this question comes in a gate, or I think gate gives in this kind of questions. I have attended the gate exams, and I found that the questions looks very dangerous. But if you have remembered the if you know the formula, so you can solve it very quickly. Okay. For the question 9, which of the following option indicates the correct flow line for preparation of edible coating material? Okay, so where here we will do what we will find out the preparation line. Okay, something you are preparing. Okay, suppose you are preparing tea in a home. So what will be the flow line? Someone will ask, how did you prepare your tea or chai? Okay, so what will you do? What will you tell? You will tell like you have taken water first. Okay, then you have put in the stove or gases or induction, whatever you take, huh? Then you have added some sugar, then chai patti, then adrak if you want, then you start the stove. It goes, okay, whatever method you are preparing, or whatever you are preparing, like it is for anything. So you have whatever you do, you have some flow chart. You will do something first, then later second thing, then third, then fourth, then final thing. Okay, so everything has some steps, one two three four, or first second third fourth. So for the preparation of edible coating, what will be the correct flow chart? So you have given four flow chart. So you can tell me by, I think by reading you can tell what will be the answer. Okay, Nancy is saying D. Okay, so what is D? Addition of sodium alginate with a continuous stirring, addition of glycerol, and heating in water bath. Okay, so uh, okay, Varuni is saying addition of glycerol, addition of sodium alginate with a continuous stirring, heating in the water bath. Okay, and Mayuri, you have any answer? Mayuri is also saying A. So let see. Okay, Nancy is now saying C. Okay, so maybe she has some uh, confusion. So addition of sodium alginate with the continuous stirring, heating in water bath addition. So okay, let's check what is the correct answer. So option C is the correct option. Okay, addition of sodium alginate with the continuous stirring. Stirring means, stirring is continuously mixing. If you work in the laboratory, that is a stirring plate. Okay, magnetic stirring or something. So if you put some magnetic stirrer and you start it, it will rotate your kind of solution. So it will continuously mixing with different components. Suppose you have added sodium alginate into the water, then you are mixing glycerol also. So that is kind of stirring. Sometimes we what we do in the home, we just the shake with the hand, or we put some what चम्मच बोलते हैं ना, क्या बोलते हैं उसको, हाँ, चम्मच, हाँ, उससे हम स्टाइल करते हैं, या ग्लास रॉड से स्टाइल करते हैं. So this kind of things, uh, stirring. But in the laboratory, we don't use our any equipment. We use sophisticated stirring unit we have. Okay, the magnetic heating stirring, that it has a both a heating panel and also the continuous stirring procedure, so that we use. So option C, what it is saying, addition of sodium alginate with the continuous stirring, heating in water bath, then addition of glycerol. So first we add the sodium alginate. Sodium alginate is a edible material, that is a coating material. Okay, so we will add into the water, then we will heat into water bath, or your magnetic stereo is there. Okay, so we will heat in that, then we will after, in finally we will add glycerol. Glycerol is a plasticizer that will make your coating very flexible, so it can fully cover your substrate, whether it is a round shape, it is a flat, or whatever. Okay, so if you have seen the biofilms, so biofilms are very flexible, so that flexibility comes with the glycerol. If you don't add any glycerol, those films will be very fragile. Okay, so we when we prepare some edible coating or a packaging material, packaging film, so we need to add some kind of plasticizer, so it will give some flexibility in the material. So that is a C is the correct option. So the correct flow line for the preparation of edible material is a millipore water, that is then addition of sodium alginate with the continuous stirring, heating in water bath, then addition of glycerol. So your coating material will be prepared. Then question 10, okay, which of the under mentioned ethylene scavenger can be used into plastic film structure commonly used in the fresh produce packaging? So we have option palladium chloride, nanosilver, charcoal, zeolite. So you only can answer if you are from the packaging or food science background. So try to answer it. Okay, whether it is right or wrong doesn't matter. So which of the material, चार मटेरियल दिया है, इसमें से which of the material can be used or are used in the plastic packaging film as a ethylene scavenger. Scavenger means uh, that eats that grass. Okay, scavenger, that ethylene scavenger is the material which can absorb the ethylene from the product. Suppose in your packet, okay, in your packet you have banana, okay, and that banana is producing some ethylene. So you have seen some pouches, okay, that is moisture absorber, also the oxygen absorber you have seen in electronic material, electronic gadgets. So that pouch is used as a moisture absorber. If some kind of moisture is there, so it will absorb that moisture. So ethylene absorber or ethylene scavenger is that also works that. Okay, so you will put some ethylene scavenger material in the any box or any perforated box. Okay, so it will absorb the ethylene. It is used in the food packaging only, because ethylene produced by the different fruits that can be ripened. Okay, that is climatic fruit. Climatic fruit means the fruits which are continuous ripening up even after we plugged. जब हम उसको तोड़ लेते हैं तभी वो कंटिन्यूसली वो राइपनिंग करते रहते हैं, सो दैट काइंड ऑफ fruits can produce ethylene. So if the ethylene is more ethylene in the packaging system, it will ripen or it will decay the quality faster. So it is better to control the ethylene content in the packaging material. So we use some kind of ethylene scavenger, or your packaging material has some inbuilt ethylene scavenger system, so it will be better to keep your food for healthy for longer time. So in this material, which is the material we use? So you need to answer. Okay, there's some Mayuri saying palladium chloride, and Nancy is saying charcoal. Okay, so we will see what is a right option for this. So option D, zeolite. Okay, okay, Varuni is saying A, but option D, that is zeolite, is used as a ethylene scavenger. We use minerals such as zeolite, active carbon, pumice, can be incorporated into plastic film structure commonly used in a fresh produce packaging. Such minerals are intended to scavenge ethylene and also modify the gas permeability of the film so that carbon dioxide can diffuse faster and oxygen can enter more readily. Nanosilver is also claimed as ethylene blocker. However, it has been tested as an absorbent pad which were placed in the tray of fresh cut fruits, melons, not in the packaging structure. Okay, so nanosteel is also used sometimes, but it is not in the packaging structure. Palladium-based scavenger are shown to have a good ethylene absorption capacity, but they are mostly tested in the sachet in the packages or stored in the room, not in the structure of packaging full. Okay, so that palladium works as a sachet, not in the packaging film. Here we are asking which material can be incorporated. So zeolite can be incorporated into packaging material or plastic film structure. Suppose we have a I made this packaging material with a paper. Okay, so I can put geolite into the making process when I prepare pulp for this packaging material. So I will put some geolite during the preparation of pulping or pressing. So my material will be act as a ethylene scavenger. So your option is D, geolite. And question 11th is what is filling the blanks is used as an active substance for the moisture scavenging in an active packaging system for maize to reduce the aflatoxin contamination. Like I explained the last question, okay, moisture scavenging, ethylene scavenging, oxygen scavenging, that is a absorbent only, that absorb the your moisture, your ethylene, your oxygen, which is excess in the packaging system. It is not good for your product, it is not good for your commodity whatever you're stored. So we incorporate this kind of scavenger in the packaging system, so it will absorb those excess material, excess component, and it will give the better shelf life. So uh, which of the active substance is used for the moisture scavenging in active packaging system for maize to reduce the aflatoxin contamination? You have option A, bentonite, sodium polyacrylate, C, calcium chloride, and D, sodium chloride. Please answer in the comment box. Nancy and Varuni saying D. Okay. Okay, so I think we'll go faster now. So sodium polyacrylate is the material is is used as an active substance for moisture scavenging in active packaging for maize to reduce the aflatoxin. The polyacrylate or salt shows the potential of for grain drying and the reducing aflatoxin contamination, particularly in developing countries. Bentonite, calcium chloride, and sodium chloride are used as active substance for decreasing the moisture content as well as reducing the browning index in the mushroom and such materials. Okay, so maize is a grain material. So rest of the material like bentonite, calcium, and sodium chloride is not used for that kind of material. So only sodium polyacrylate is used for the grain kind of material to scavenge the moisture that protects to develop or production of any aflatoxin. Which of the following is used as sterilant for the spices? So your options are carbon dioxide, ethylene oxide, chlorine, and sulfur dioxide, ethylene gas. So you need to answer which is the used as a sterilant. Sterilant means when we sterilize. So it sterilize means your product is free from any kind of contamination. Okay, so which material is used to sterilant for spices? So you need to answer A, B, or C, or D. Please answer in the comment box. Then we will go forward. B. Varuni is saying B. Nancy is saying C. Okay, okay. So we will see what is answer. So option is correct. Option is D. So okay, I need to check the for this. I think I have put a wrong answer here. Let me check what is the correct answer. Okay, so that who has given the answer? Varuni is saying D. Then she said B. Then Nancy is saying C. So let me check what is the answer. So option A, that is ethylene oxide, is used as a sterilant. The chlorine is used to bleach the floor in sanitize equipment. So sulfur dioxide used to inhibit the enzymic browning in the dried food. Ethylene gas is promotes to ripening of fruits, and ethylene oxide is used for the sterilant for the spices. So your option A is correct option, that ethylene oxide is used for the sterilant in the spices. Then, which of the following satisfies the condition for ultra low oxygen storage? So here, hello. Okay, 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 okay. Here, sterilant means sterilant. I told you, okay, sterilization. So the sterilant is the material which used to sterilize your spices. So here, chloride or chlorine is used to bleach floor or sanitize equipment. Okay, so that is out of the your option, because it is used to bleach your floor and sanitize equipment. Sulfur dioxide is used to inhibit the enzymic enzymic browning. Sulfur dioxide, that is used for the reduction of your enzymatic browning in dried foods. And ethylene gas is used to promote ripening. Ethylene gas, जब what in a banana or any kind of mango, so we use ethylene gas to promote or to accelerate the ripening process. But ethylene oxide, that is used to sterilize or sterilant as a sterilant for the spices. So here ethylene oxide is the right answer for this question. Ethylene is used as a sterilant for spices. Okay, because chlorine is used to bleach floor and sanitize. Sodium dioxide is used to enzymatic browning, and ethylene gas is used for your ripening of product. So your ethylene oxide is the only option you have. So that is the correct answer, that is ethylene oxide. You got it? Okay, okay. Which of the following satisfies the condition of ultra low oxygen storage? So here you need to tell ultra low oxygen storage. Ultra low oxygen storage. In ultra low oxygen storage, what is the condition of what is the amount of oxygen or carbon dioxide present? So option A, 1 to 1.5% of O2 and 4 to 5% of CO2. B, 1 to 1.5% of O2 and 2 to 3.5% of CO2. 0 C, 0.5 to 1% of O2 and 4 to 5% of CO2. D, 0.5 to 1% of O2 and 2 to 3% of CO2. So if you know the answer, you can please write to the in the comment box. Then I will tell. what is the right answer for this? Okay, Mayuri is saying C. Okay, 0.5% to 1%, and 4 to 5% CO2. Anyone else? Varuni is saying C, that is D, 0.5% to 1%, and 2 to 3% of CO2. Okay, anyone else? Okay, so let me. So option D is correct option. Okay, point 1 to 0.5 to 1% is a CO2, and 2 to 3% is CO2. Okay, so Varuni, you are correct for this question. And okay, so this kind of storage is used for those products which requires low amount of oxygen. Okay, which requires very minute quantity of oxygen for storage kind of, so you can store your product for longer time. So that is a ULO, that is a ultra low oxygen storage. The oxygen level closest to minimum level required for the maintenance of the plant tissue. Lower level of induced disorders such as browning tissue, and that is at 1 to 2 degree centigrade with a level of zero point 0.1 to 0.5 to 1% of O2 and 2 to 3% of CO2. So that is your ultra low oxygen, and that is mostly used for the maintenance of plant tissues. Okay, when we grow plant or plant tissues for some kind of any medicinal or tissue culture, so that we use this ultra low oxygen storage. Okay, so this is I've written the question number wrong. That this is a question 14th. Which of the following chemical helps to reducing the post-harvest ethylene production in fruits? So options are ethylene hydrazide, 1 uh, methyl cyclopropene, and C is cetyl pyridinium chloride, and the D is potassium sulfate. So which of the chemical use or help in reducing the post-harvest ethylene production in fruits? Please answer in the comment box. So Nancy is saying A, that is ethylene hydrazide. Varuni is saying potassium sulfate. Okay, Mayuri is saying C. Okay, so let's see what is the correct answer. So B is a correct answer. Methyl 1 methyl cyclopropene. 1 methyl cyclopropene is a ethylene action inhibitor. It is wo- that is work as a ethylene inhibitor. Okay, that reduce ethylene production. Thus, delays the changes in caused by the plant hormone ethylene, such as ripening, softening, and undesirable color changes in fruits. Okay, so I'll tell you one thing. In mostly fruits and vegetables that is climatic, okay, such as banana or mango. Okay, so that ripening, okay, from the early stage to the final stage. Okay, जब वो छोटा रहता है तो पका नहीं रहता, that will be green color, but due to ethylene gas that ripening, that color changes, also softening process happened. But after it some stage, okay, after its full ripening stages, if you are not plucking it, it will be decaying. पूरा पकने के बाद वो फिर आप उसको और छोड़ दोगे तो that will be decaying. So the faster the ripening, the faster the decaying. If your ripening stage is ripening process is very slow, so it will be slowly ripening will be happen, and the decaying is also will be slow. So to slow the ripening process, 1 methyl cyclopropane is used to inhibit the ethylene production. So option B is the correct answer, and that is, I think, our last question. In Tal prolong, fruits are coated by palm oil, palm oil, nylon, CMC, acetic acid. So please answer your option in the comment box. In Tal prolong, fruits are coated by palm oil, nylon, CMC, acetic acid. Nancy is saying C, CMC. Okay, Varun is also saying C, and Mayuri, Nancy. Okay, so all are you saying C? So let's see what is the correct answer for this. So C, you all are right for this. Tal prolong is a method of coating fruits to prevent from its ripening. If in this process method, foods are coated by the carboxymethyl cellulose. Carboxymethyl cellulose is a kind of biopolymer that we make coating agent and we apply on the fruit. Okay, so it prevent the ripening process because there will be no production of ethylene, or there will be no extra gases will be not there like oxygen or carbon dioxide. They will be protected from the outer environment, so it can stored for longer time. So option C is correct answer. All are the given all have given the good correct answer. Okay. Okay, question number 16, I think this is the value of respiration quotient is fill in the blanks if the substrate is liquid. अगर आपका प्रोडक्ट लिक्विड है तो value of respiration quotient will be higher than unity, higher than 1, equal to 1, lower than 1, or all of the above. Please answer. Your substrate is liquid, then what will be the respiration quotient? Okay, please answer this question. Varun is saying okay, Nancy. Varun is saying C, Mayuri is saying A, and Nancy is also saying A. So let's see what is the correct answer. So option C is the correct answer. Okay. So if the substrate is liquid, the respiration quotient is always lower than unity because the ratio between C and O, that is carbon dioxide and oxygen in liquid, is lower than the ratio in carbohydrate. If the substrate is in acid, the respiration quotient is higher than unity, and the respiration quotient is normally assumed to be equal to 1 if the metabolic substrate are carbohydrate. Okay, so your product is a substrate is a liquid, so your respiration quotient will be lower than 1. So this is your answer. So that's all for today. I hope you liked it, and if you have any question regarding any confusion, you can write me to this mail ID you are seeing on the screen. I hope you have liked it, the class, and you understand all the questions what I have explained you here. So this is all today. Thank you for listening. Now you can leave the class. Thank you all for joining with me. I hope you will join from the next class also. Thank you.